with Tesla coils, and one of the ones was talking about where they put wood on the terminals, and sometimes they got like a little bit of a glow inside, and other times the wood just exploded into like 1,000 little splinters. It was like it broke the bonds, and plus the stress of it. But I mean, yeah, there's stress there, but you wouldn't think it would be enough to break anything.
Yeah, Nathan and I were talking about that the other day with wood accepting charge.
Yeah. And also how with twisters, how the wood goes like when entering one other, essentially one of the Hutchinson effects or the reported Philadelphia effects of matter becoming disintegrating or becoming gel, or not even just like a foam.
You mean like how stuff ends up in trees that way?
Yeah, this disintegrates and then lets a solid object pass through part of it that materializes with the other solid completely in it without forcing itself in, sort of thing.
Yeah, like the 2x4 through the telephone pole in Altona, Manitoba one back in the 90s.
In an old alien scientist video, he mentioned that I may have this backwards, but if you go above the atom's resonant frequency, it was either above or below, but it could cause a phase change. And I've asked him about that since then, and he just said he didn't get into it too much. He didn't have the details. I don't know if he was afraid to go further, but I can't find any reference for that anywhere, being able to cause a phase change like that, to where he could turn a solid into a liquid. But if anybody knows anything about that, I would certainly not like to know what it's called. And if there's any experiments.
And who was the inventor of that?
In fact, demonstrated some kind of like jellification of the metals.
That was Jeremy Reese, alien scientist. One of his old videos that was talking about that day we're not supposed to talk about. Trying not to get you dinged, but what I'm talking about.
No, I gotcha.
That looks like a nice HG glow. What do you got going on there, Jeremiah?
And welcome, sir. Oh, you're muted. If you're
so, don't mind the sound of the vacuum pump. Sorry about that in the background. Try to get real in close on the Mercury here. So I'll show you what's going on a little bit. Underneath here is a rotor, and this rotor is a 4-pole BLDC or brushless DC rotor from an in runner, and spin it up on the Dremel, and so it produces a rotating magnetic field that swirls around this. And inside this test tube is another tube there. Yep. And it's hollow on the inside.
Oh, okay, good.
So
I was hoping you weren't spinning the glass.
Right, that can slip right over the rotor, and so when we spin up the rotor, we can see that it drags the Mercury around with it.
Nice.
Oh, that's so cool.
Is that like the semicircle, like half north, half south? I can't think of the word for it, but it's not up and down like a torus. It's side to side.
Sorry, say it one more time, because again, I'm right next to a vacuum with a Dremel tool that's making a heck of a sound. So,
right. Which way were the magnets polarized? Yeah, which way were the magnets polarized?
So the field lines close from the outside. They come north out to a south, south out to a north, north out to a south, and south out to a north to close it. So it's a 4-pole rotor, and those field lines come out and they close back around through the liquid loop of Mercury, which is basically just a solid cylinder.
Right.
That's hollow. And so the magnetic field encompasses it much better than our previous test tube experiments. And so right now it's under high vacuum. And I don't want to run this for an extraordinarily long time because technically there is a tiny amount of mercury vapor that's making its way up the vacuum nozzle and being pumped back out into the vacuum pump. And so I don't want to get that into the atmosphere that I'm breathing. And after this, I will have to open up the windows and vent the place out just for basic safety protocol because I don't have a mercury particle density detector.
Yeah, maybe do that outside because if that breaks,
right. But
dangerous.
no, I do
liquid,
have
though.
a cache tray that I'll be placing underneath it right now, and that's just in case. But I can spin
It's
this.
the gas mercury
Unfortunately,
that's
lights aren't
dangerous.
dark enough right now. But if the lights are completely turned off, there is a triboluminescent glow, and you get these bubbles that kind of get dragged along the surface here. You can see them. So there's a triboluminescent glow under extremely high vacuum. It's just so dim that we can't see it clearly with the eye. If I add the rotation, I'm going to add some high voltage now too from a high frequency AC source.
Do you think that's like an electrostatic or like a cavitation effect for when you're shaking the mercury and getting the light?
Oh, it's well, we're getting both. We're getting both the air cavitation effect, and we're getting an electrostatic phenomenon.
Okay, oh, cool.
That's nice. Is that the
How
glow
much
at the
power are you
top there?
putting in that?
About 35 watts.
Oh, okay. Well, that's a pretty decent amount.
That's awesome. Appreciate you joining and sharing.
Yeah, that's really
There's
cool,
a-
Jared.
A rotating magnet on there? Oh, yeah, I see.
Now, maybe if you could put something on the inside of the tube just in case you do bump it.
Oh, it's already got a plastic lining, if that's what you're wondering.
Yeah, just so so the rotor doesn't hit it, or if it does, protect it.
Yeah, it's got a plastic lining in case the rotor does bump it. So there's some safety factor already in place, and then there's a catch tray underneath it. So
that's
if
good.
something does go incredibly bad, then there's some place for all.
I'd hate to see it break and you just like accident and inhale it.
You know, the fluorescent bulbs have a small amount of mercury in there.
Yeah.
So if you break one, you know, open the windows,
Makes you wonder how much
sweep
your
up
houses are
and wash the
contaminated
floor.
with them breaking.
Mm-hmm.
Believe it or not, there's more. You got to worry more about feelings than anything else when it comes to mercury.
Yeah. Seen some places where they were talking about that being an EPA thing if you just break 1 CFL.
Well,
Yeah,
I'm not
it's more dangerous to have fillings, amalgam fillings, than anything else.
Probably, yeah.
Or to wear felt clothing or felt hats. They're made with. They have mercury. Felt has wool. Wool naturally has mercury in it.
Really?
Yeah, the old Mad Hatter thing.
Yeah, that's where the Mad Hatter comes from. The felt hats, right? I actually made that mistake once. I bought a hat for a 10-day hike, and I wore it for 10 days. And I do recall having some mental issues some months later.
Does it still put off a little bit of vapor?
The felt.
That's why I got one of the because
right.
You
Mad
Mad
Hatter.
Yeah, that's
well, that explains a lot.
I wouldn't wear
Oh,
I
so
do.
that's where you extracted the mercury.
So I usually plug my card into the side here. There's a really nice slot, and my LED card will light up the nice side with the good settings.
Heck yeah.
That's a felt hat.
A wizard matter hat.
I like that. That's neat. Do you have a cane that goes with it?
Well, no need for a cane when you
light.
carry around a wand.
That works.
That's right.
And you gotta have a monocle too.
It shoots lightning. And
that it does.
Wow.
Oh, the electric magic wand is way too much fun. I'll be honest. Like something that you can basically flip out a piece of plastic from your pocket, and make a 1 foot long lightning bolt with something that you're just holding in your hand. Now that's pretty nifty, and so is the levitation.
You're getting a foot out of that? You're getting a foot arc out of that thing? I mean, it's not very narrow.
Well, there's a bit of a trick to make it reach that kind of outside potential. So it only has 130 kV output capability on its own, and 130,000 volts is still nothing to mess around with, because that'll give you a 5-inch spark no problem on its own. And if you get the impedance match right and it's a low humidity day, you can get more out of it. It used to actually try to arc down the sides of the wand and go back to the user handle, which was no good, because if your hand was a little too far up on it, then it would try to ground out to you. But yeah, it would arc down the outside, and I've had that thing kind of go into a runaway mode where it's drawn about 6 or 7 amps off those little double cell batteries, and it's wonderful because, well, if you use some polypropylene film, which is what I can roll up and throw in my pocket and carry around, you can use the polypropylene film in 2 layers to create a mobile capacitor by surface charging. No need for foil, no need for any kind of conductive surfaces. The ions in the air will do just fine as a conductive plate. And so you can create this multi-layered capacitor by charging up each plate to over 100,000 volts, and you can just throw them on top of each other, literally just tossing the plates on top of each other until they reach such a high potential that they'll create over a foot long lightning bolt that just leaps through the air.
Was that
And
also
so
how you
pretty
can,
nifty.
what was it called? Where you get an arc, but it doesn't branch out. It's just very straight. I can't think of the name of that you called it.
No, this one does tend to branch out quite a bit, and the reason for why it branches out is it doesn't have an actual plate on the surface of the dielectric. There's no metal conductor to set the boundary conditions, and so free flowing ions just are deposited from the atmospheric gases, and they stick to the surface. And on the negative side, free electrons are pulled up and they stick to the surface. And so they'll get.
Part of it was wanting to follow the magnetic field of the coil, but does that?
Well, there's no
that have
coil.
anything to do with it?
In this case, it would be
Oh, it's
purely
not a link
DC.
coil. It's like Tesla coil.
No coil in this case. This is purely DC high potential electrostatics delivered
really?
with quite a bit of current. Yeah. So, I mean, technically, it falls under the category of electrostatic systems, but technically, it's not an electrostatic because it's an electrodynamic system due to the flowing charge. This system operates primarily by transporting charges from one place to another, and it does that through a cascade multiplier. And it's all built it right into the wand. And so, like, Electro Boom copied my wand because, well, he wanted one for his, 4 million subscriber self-celebration.
Who's Electro Boom? Never heard of him. Sorry.
That's
funny.
It's well said. Well said.
4 million subscribers, and I haven't heard of him.
Yeah. You ever see the guy that the Russian does his
algo's not pushing in my way? I don't know.
Oh yeah, that guy's great. His heated seat was the best.
Yeah, he referenced my channel when he was making his video about his homemade electric magic wand, like several years after we released ours. And he's like, he showed a brief clip of our video and said, well, these guys use 100 picofarad capacitors and they try to make it safe. I don't care about safety. So he used these big, like 1,000 picofarad
he's one
caps.
of those sky jumpers.
That's dangerous.
Base jumpers or whatever. What do you call it? Parachuters, or the guys that like to jump out of planes with a parachute for fun and pay for it.
I don't want to necessarily promote this guy's channel, but if you haven't seen it,
risk takers,
you should at least be familiar with like his electric magic wand video, because you see little clips of our stuff in there. But anyways, this is a fantastic device to carry around. I usually travel with that and the Tiny Titan Tesla coil, which is this little palm-sized Tesla coil. It stands about 3 inches tall, can produce a little over a 3-inch spark, and it can run off a battery pack. That's 3 inches tall with its battery pack. It's about 2.5 inches tall without that.
How long does it last? 5 minutes? And you got to recharge?
Yeah, about 5 to 12 minutes. One of the reasons why it lasts a little longer is because it recycles its own energy. And so as it's running, the ground feedback current that's in excess of the MOSFET gate drive potential gets clamped back to the power supply and recycled. So it gets pumped back into the battery pack.
Looks like he's pushing a lot of amps to it, too. Each pulse.
And so we end up with roughly about 110 amp pulses in this little handheld unit.
Oh my God.
That'll kill you. That'll kill someone. That hits you all in the hand.
Well, no, that's on the primary circuit, because by the time it actually gets transformed through the secondary circuit, then you're ending up with a ratio of several thousand to 1 due to the fact that you're operating in resonance.
Decreasing on the output. It's not
right. Well, you're turning your current into potential on the output. That's effectively.
He's sacrificing the amps for the high voltage.
Right.
How did that guy get flames out of a metal hinge? Was there gas underneath it?
Flame? Oh, you talking about the electric magic wand video?
No, the video that's on right now. Just a second ago, it showed a metal hinge, but it was on fire, or it looked like it was on fire.
Oh, he's showing my electric magic wand video. Okay, now I wasn't looking at the screen. I'm sorry. Yes, there was vapors on this. Yeah,
Through
so
Electro Boom, we gotta play yours.
Yeah, this is my magic wand video. This it's just showing you like what this thing can actually do. So we go around with this thing, and it's always entertaining.
Hey, that's a great way to get rid of lice, you know.
Well, it will do that too. Actually, so if your trash can stinks, you can just kind of pull the bag out and stick this thing inside. It'll produce ozone and it'll sterilize the surface.
I wonder how insects react to that kind of field.
Yeah, so that's me there with the caveman hair. My hair is much longer now, but here we're destroying some toroidal rings.
Was that a smoke
vapor by?
Oh, is that what that is? Okay.
Yep. So we got these little toroidal smoke rings. We're blowing them to pieces. As soon as the electrostatic field touches them, the particles get charged and they fly apart by Coulomb forces.
You know, Stan Deo did this without any power. He used the diaphragm.
So that's the driving circuit. It's your basic Maselli ZVS, except for it's slightly modified. Okay. And so that's the entirety of what's inside the electric magic wand in the first version. Now, I've gotten a version now up to 3.0. So that's version 1.0. 3.0 has a full phase shifted driver inside of it, H-bridge configuration. And that thing can deliver 300 watts, which is significantly more than this. So what Wand 3.0 will do above and beyond this one here, and you can just see the power supply there, Arkin. What Wand 3.0 will do is actually generate a beam of current that comes pouring out the tip of the wand. And so if you've ever seen that, that Harry Potter scene where, what's that guy's name? Dumbledore, I think it is. I'm not much of a, not much of a huge fan of any particular series, but yeah, so Dumbledore pulls some memories out of his head with his magic wand, and there's like this beam. It looks like a thread of plasma that kind of comes out of the side of his temple. And so we can actually produce that effect. And I was able to use Wand 3.0 to actually connect with my temple. Not to say that it pulled any memories out, of course, but it produces the same visual effect. And it's a real three-dimensional plasma that is roughly about 115 degrees Fahrenheit. It's an incredibly cold plasma considering the amount of luminosity it puts out. It's quite visible with the naked eye, even under lit conditions. And at about 300,000 volts, the acceleration potential for a negative output is sufficient in order to cause ions to generate a beam that can connect from one point to the other through the open air over a 6-inch gap. It's just incredible. The truth is that you could create a lasso at about maybe 2 megavolts that you could grab onto an object at a distance with a plasmatic beam, and then you could use AC to modify the stress in that beam and actually pull things with it, which we've also played around with a little bit. So yeah, you can use plasma to exert physical forces on external objects, physically pull them or push them.
Is the plasma hot enough to burn you?
What's that?
Is the plasma hot enough to burn you, or is it even
no?
It
doesn't burn you. It rolls over your your skin. It feels warm. It's kind of like you placed your hand under running water, like under a hot running tap water thin stream. Right. And other than that, no, it's super strange. Now, if you get too close and you concentrate it down onto a very small point, it will get hot. But it tends to spread out due to the fact that the impedance of the atmosphere is so high. The arc will take a beam form and travel from the high voltage tip of the wand over towards your hand or your skin or whatever object is touching. And then right at the surface, it'll tend to spread out almost like it forms a little cone. Kind of looks like a tube attached to the end of a suction cup. And so this glowing stream spreads out wide like a suction cup, and then it distributes itself across the surface, which is, again, one of the really weird things that extremely high voltage does. And this is only at 300 kV. Now, we've seen some really weird stuff at about 1 megavolt.
Is that at high frequency or is that DC?
That's DC.
Really?
Yeah, really. I know that was the most surprising part to me too. I didn't realize that DC high voltage would have these kinds of effects. or form physical structures that would represent almost solid tubes or plasma beams. These were all surprises to me when we first stumbled across them, and that was many years ago.
Oh, you remember a while back when we did that experiment with the skin resistance?
Oh man, that
online?
was a while ago. Yeah, like
Yeah,
remind us
I
of
was
all the
just
details.
thinking the cells probably have a breakdown voltage. That's probably why the 40 volts does it. And I was just remembered back when I did it when I was a kid, I did it like 1 inch apart. I did it 4 inches apart when I was doing that experiment. So since I got about 9K for 4 inches, that was about 1.5K per inch,
Wow.
maybe lower.
Wow.
I wonder if it matters if you're, when I did it, I don't know, I was like 12. I wonder if that matters too. Because, I mean, you know, your body, you know, the younger you are, you probably have more water content.
Actually, the whole body conductivity phenomena is one of those things that's been documented by some of the strangest organizations. I'm trying to remember if it was Monroe Institute who did skin conductivity tests, or if it was also combinations of the CIA released papers.